Example 32, an equilateral triangular duct having a horizontal base of 1 meter carries a critical flow of 1 cubic meter per second. Assuming roughness coefficient of 0.016, calculate the critical depth, the critical velocity, and the critical slope. So that's the cross section. Remember, that's not rectangular. So this is the critical depth. I'll call this x. This one is x also. The total horizontal base is 1 meter. And it is an equilateral triangle. Therefore, the top width of the water surface would be 1 minus 2x. So, formula for critical depth, capital Q square over G equals area critical cube over top width, where tangent of 60 degrees equals d sub c over x. So x therefore is square root of 3 d sub c over 3. So that area is 1/2 of upper base 1 minus 2x, 1 minus 2 square root of 3 over 3 d sub c, plus lower base 1 times d sub c, area of trapezoid. Simplifying, area is d sub c minus square root of 3 d sub c square over 3. Then top width is 1 minus 2x. Substitute 1 square over 9.81 equals d sub c minus square root of d sub c square over 3. Quantity cube over 1 minus 2 square root of 3 d sub c over 3. So, by trial and error or using the high-tech calculator, d sub c is 0.4931 meter. The critical velocity. So let's compute the area critical. V sub c is Q over area sub c. And area sub c is, from this equation, 0.4931 minus square root of 3 of 0.4931 square over 3. So area sub c is 0.3527 square meter. So therefore, V sub c is 1 divided by 0.3527. So the critical velocity is 2.835 meters per second. Or we may use the direct formula, square root of G hydraulic depth critical, as an alternate solution, so that you will be exposed to different ways. Hydraulic depth critical equals area critical over top width. So the top width is 1 minus 2x, 2 square root of 3 over 3 of x. Top width is 0.4906 meters. So substitute here. V sub c is square root of 9.81 times area 0.3527 over b 0.4306. So we will get the same answer. Then critical slope. So since V is 1 over n, hydraulic radius to the 2/3 slope to the 1/2, then critical slope is quantity n v over hydraulic radius critical to the 2/3 quantity square. So nv sub c or hydraulic radius critical square. So we already have v sub c, we have n, hydraulic radius critical only, which is area critical over wetted perimeter. The wetted perimeter is 1113 meters, then less these two sides, unwetted sides. This is not included in the wetted perimeter. This is also 1 minus 2x. So wetted perimeter is 3 minus 2 times b, which is 0.4306 or 1 minus 2x. B sub c is 2.1388 meters. Hydraulic radius therefore is 0.3527 over 2.1388, 0.1649 meters. So substitute. S sub c equals quantity 0.016 times 2.835 over 0.1649 to the 2/3 quantity square. So critical slope is 0.02275.